So I hope you have a pencil, paper, and that you're ready to get to work on the RSG of 2.3. So for the ready, comparing rates of change in both linear and exponential situations. Identify whether situation A or situation B has a greater rate of change. So when we look, we're looking at those top two. So how do we get from negative 48 to negative 43? We add 5. How do we get from negative 3 to negative 38? We still add 5. Negative 38 to negative 33, we still add 5. On the other side, negative 10 to negative 9, we add 1. Negative 9 to negative 8, we add 1. Negative 8 to negative 7, we add 1. So right over here, this is our change in y, and this is our change in x. So our rate of change for this problem is 5/1. It's always the change of x is on the bottom and the change of y is on top. So let's look at B. We'll go from the one right here to another point right here and look. So if we look, we're going up 1, 2, 3, 4, 5, 6. We went up 6, and we're going over 1 plus 1, which is our x value. So the rate of change here is plus 6/1. Which one is greater, 6 or 5? I would say 6. So B has the greater rate of change. So you should be doing that for 2. You should do that for 3, 4, and 5. Now for the set, recognizing linear and exponential functions. Based on each of the given representations of a function, determine if it's linear, exponential, or neither. So the human population of a town is decreasing at a rate of 1.5% per year. I would say because there's a percent, this is exponential. And that's all you got to do. So you're either saying it's linear, exponential, or neither. Please do those for 7 through 11. And finally, the go. Geometric means. For each geometric sequence below, find the missing terms in the sequence. So this is exactly like what we saw in that in module 1. We're just reviewing it. So we're going to take 162 and we're going to figure out how many carets there are. 1, 2, 3, 4. We're going to divide it by 2 because that was the start. So 2 goes into 16 8 times, minus 16. This is 0. Bring down the 1. 2 goes into 2. 2 goes into 2 1 time. We were supposed to bring that 2 down. Sorry, my bad. 2 times 1 is minus 2, so it's actually 0. So our quotient is 81. Now we're looking for a number multiplied by itself 1, 2, 3, 4 times. That's going to get to 81. So some number, x basically to the 4th power, has to equal 81. So in this case, it's going to be 3 times 3 times 3 times 3. So now I know 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162, so it checks. So every time we're multiplying by 3 times 3 times 3 times 3 times 3. So please make sure you do all of those goes as well.